right, so obviously it's gonna take a minute to figure out if this is working or not, but we're gonna need everybody in the chat to tell us if this is back up live or if we're just or what's going on.
Says the stream health is green. Looks like it might be okay, huh? We good? Yes?
Okay.
Nothing yet. We have more frames.
Okay, sweet.
All right. Well, that was a great
Looking way better.
podcast, guys.
Yeah, thanks for joining us.
We'd like to thank Nick from HD Retrovision for doing such a wonderful job hosting it this time. Glad you guys have a professional here to save you. So.
God.
All right, well,
All
on
right.
that note, I'm fucking starting it off. So here we go. A new kind of absinthe. Leatherby.
All right. So, welcome back, everybody.
Welcome.
For those who have joining us for the first time, if there are any of you, and probably left already, the way we usually do this is we go around the circle here, do a little individual topic of the week, and then we have a couple of group things, and then at the end we answer questions from that were like left on the video from last time. And if we have extra time, we'll try to get to stuff that's flying in the chat, but we'll see how we do with that. So yeah, let's just go right into stuff. Who wants to start?
I will, I guess, because I had a lot of
ahead,
fun
Bob.
yesterday.
Go for it.
I've always wanted to see what the difference was between an RGB modded consumer grade TV and, you know, a PVM and a BVM. So yesterday I wanted to do a live stream because one of my friends, Art Sabin, actually suggested that I start doing more because he said a lot of people might dig it. I didn't think so. I thought everybody would be like, what are you doing taking pictures of a monitor? But I guess other people enjoyed it too. So I did the whole thing, and I really tried to get as good as I could comparisons between the different types of tubes. And I thought it was really cool. So, you know, a lot of it you have to really experience in person. Like the BVMs almost don't look as good as a PVM when you're watching the picture of it. But it was like the consumer grade TV that was RGB modded was actually great. It just it had a different kind of mask behind it, and it obviously had way less lines. So, but I mean, it was very cool to see. So I'll hopefully get like a formal video up because that was just a fun live stream that was not formal. Hopefully, I'll do one of those next week so people could actually see the differences, and I'll post the raw images that have been processed. So I had a lot of fun with that one.
Yeah, that was a great live stream. I was in there until the point you started messing around with a plugged-in CRT with the back taken off, and I couldn't do it anymore. My heart was just too stressed out, like wondering whether you were about to die at any moment.
You know, we all got a drop, and wouldn't it be fucking just the most poetic justice if that's how I go? Live streaming a CRT and just Retro RGB gets killed by his own passions. And I don't think anybody knows where the office is. So you guys would have to track down Jose. You'd have to find Jose and Ben on Twitter, and then tell them to go down to the office, or at least call an ambulance and figure out where I am, because no one knows where my office is. So, yeah, that would have been epic.
There's a saying for CRT repair techs, right? You need two things to be a good CRT repair tech. You need technical know-how, and you need a defibrillator somewhere.
Which cracks me up because
right.
the electrical shock stops your heart, and then another electrical shock would start it back up again. So shouldn't somebody just throw the tube on me if I get zapped with it?
Yeah, that's right.
Yeah, they better use the BVM to do that as the higher quality shock.
Right, exactly.
That's awesome.
All right, Zach, I think you were going to go next, right?
I don't know. Was I, Nick?
I thought you said you wanted to go.
So, yeah, a couple things I've been doing. The Commodore 64 diagnostic software. That's still very deep into that. Kind of put that on the shelf, though, for the AES stuff that's coming very, very soon around the corner. A good RGB mod or bypass solution for AES systems, and a complete analog RGB output modification for any MVS hardware arcade revision. Now, that's all well said and good, but also right now, as we speak, Voultar is designing and breaking ground for a brand new laboratory / office in his backyard. So hopefully within the next week, I will begin, if everything goes beautifully, a short mini-series of me by myself breaking ground and constructing an office with just my hands and body.
So you're going to do a video series on your punishment shed?
I'm going to do a video series on the yes, exactly, on my.
I can't wait till you get halfway done and you bring your blow-up doll out there, and all your neighbors are like, "What the fuck?"
Well, what I thought about doing, just real quick to kind of set this shot up, I thought the first shot of the series will be a lawn chair sitting there in the backyard. I have a pretty big backyard with Claire, the blow-up doll, sitting in there with a beer, and she's looking at me. And I've got like a camera set up, and I have, pictures taken of me breaking ground, and Claire is like, the press. I don't know.
I like it. I'm sold.
Whatever. So those are the two big things that are most pertinent at the moment. I've outgrown this house. I have a pretty big house, and I've got a really good-sized garage, but that's just not working anymore for as far as doing any R&D stuff and all the other stuff that I do. So I really need to have a separate space, and that's just consolidated and used exclusively for all of this stuff. I'm outgrowing my loins here.
I know the feeling.
Cool.
So that's it for me.
I'll go. I can go.
Cool. While you're going, Zach, fix your microphone. It's goofing up.
Yeah.
I don't think it's my microphone. I think it's the upload, because when other people talk, I'm hearing some lossiness.
Okay.
Oh, okay. I want to talk really quickly about some Famicom to NES converters, because when I asked people on a Facebook group about what they thought was the best Famicom to NES converter and what I should get, a lot of people recommended me this thing, the Honeybee converter, right? It's great for the top loader, and it's great for the toaster as well, because it's got like a piece of fabric on there that you can use to pull this out of your NES, so the Famicom game doesn't get stuck in there, right? Like if you just pull out on the one piece and this gets stuck there.
Yeah.
Yeah, but obviously, as a good engineer, the first thing I did before I even tried it is I opened it up, and I was appalled at what I found in here. See so to enlighten the viewers, a major difference between Famicom and NES carts is that NES carts have a security lockout chip inside of them, and Famicom carts don't. And so if you're going to make a converter that takes a Famicom game and allows you to play it on an NES, you need that security lockout feature on the converter in order to allow the Famicom game to load up, right? And for the longest time, nobody was able to crack that the security chip, right? And there was a whole legal mumbo jumbo with Tengen back in the day where they were able to get some Nintendo is the patent documents, and they were able to reverse engineer the chip from that, so on. But during this time, what a lot of people resorted to, and what this company did, is that they put just like a little charge pump on here with a transistor and a capacitor, and they just zapped the hell out of the NES security lockout chip inside the console long enough for the game to boot up, and the security chip inside the NES remains in a frozen kind of latch up state for the duration of that power on cycle. So this is very bad. I mean, if you use this thousands of times or hundreds of times, I don't know. I mean, I haven't really tested it. You probably end up killing something in your console. I mean, luckily
I think you need another article about it.
Well, I'm not going to write an article about this, because if you're going to kill something, you're going to kill the lockout chip, and I mean, then there's two failure modes. Either you fail in always reset or you fail in never reset. So if you're lucky, you'll fail in never reset, and then you effectively did a blinking light win solution on your NES. the really tough way, right? So yeah, if people are gonna start using converters, I highly recommend you open it up and you check. And if you don't find like a chip in there, if you don't find an IC that has like at least 8 dip or whatever, then it's most likely a charge pump, and it's most likely a very bad solution, a very bad way to fool the NES into loading the game. That's all. So honeybee converter equals very bad.
So not only did you ruin ROM carts for us, you ruined honeybee converters. Thanks, René.
You're welcome.
I can go next if Bob. I threw an image in the chat. Are you able to put that up on the screen?
I will try.
Is that gonna wreck everything? Like, if you want to take your time, we can let Steve go in front of me if you want to take your time to do that.
Yeah, that probably just messed everything up. But hold on 1 second.
So Renee, I went and got that official one that they put in the NES carts back in the day when they were short on carts or cart PCBs, where they put Famicom boards inside the NES cartridges, and they had this thing. This is the official Nintendo one. So.
Yeah, so it has the real chip in there that's calculating the hash at the same time as a security chip inside the console.
Here.
Yeah.
That's a 10 NES.
The PCB is NES-joint-01.
Newer repro carts actually use an Atmel AT-Tiny 13A.
Right.
The firmware was developed by Crix, actually, so I mean, he does do some good stuff, and that firmware is open source. So anyone who's releasing an NES cart nowadays is using that AT-Tiny with Crix's free software. So if you see an Atmel part in a converter that you recently bought, then it's good. It's operating at the right voltage. It's doing the right thing. It's correctly doing the security lockout features.
Wasn't there like a PIC that they used to use? I think RetroUSB used to sell them.
Mm-hmm.
Maybe still does.
Yeah, but you can't. There's the firmware is not available for that.
Right. But that was the first iteration, and then Crix wrote his own that was open source, right?
That's right.
Yeah. Okay.
Yeah, you can get the firmware for the that Ikari released, which does the CIC for the SNES.
Right.
Chip that he's using on the SD to SNES, and apparently it's only the seed values that are different between the SNES and the NES versions. So you could theoretically just take that PIC assembly code and change the seed values, and have a NES lockout chip on PIC, because the PICs are cheaper. So.
Excellent.
Cool. So Bob, what's up? Are you able to do an image or no?
I am actually. I'll do that right now.
All right. So before you get that up, all right, if it's already up, let me know. But I can quickly mention, if you haven't already, these shirts are awesome. I'll put the link in the chat or in the description afterwards. It's a fundraiser, helps an animal shelter down in Houston. But in any case, if Bob's got the image up on the screen, what I was going to talk about is something he asked me to bring up as like a follow-up to last week, when we were talking a bit about color spaces and what's kind of going on there mathematically. And this is a very related topic, which is chroma subsampling. So often you'll hear about video that is either 444, 422, 420, and there's some other ones that I don't really know what they get used for, if they get used very frequently at all. But I'll kind of just give a kind of a overview of what's going on there real quick. When you hear the term 444, that can really either mean just a full RGB or YCBCR digital image. doesn't really matter because you can convert between those two losslessly in that case. So in the other cases, there's some interesting stuff going on there. And if you remember what I was talking about last week, if you were there, you have this concept of effectively rotating an axis to put a bunch of the variation in your image along one axis. So if you're looking at the picture here, I've simplified this down to 2 dimensions. You have an R-axis and a G-axis. And one thing you'll notice in my picture here, it's somewhat representative of real life, is that pixels tend to be correlated along a line. So if you know the R value of something, often you can predict the G value of something. And so what that means is you really have an oversampled data set. You are encoding too much information, or more than you really need. And so one thing that you do when you go to a different image space is usually called decorrelating data. You put most of the data variation along one axis, and that is that axis, usually called the y-axis. It represents the brightness of an image. And what that gains you is your other axis has very small values. So you'll notice just by changing the axis of how I view the world, all of a sudden, these points that I needed, for example, to encode that point with 3,3, now I can encode it with 2,0.1. So that second number is very small. So now, to get into what's going on with Chroma Subsampling. So since all of your energy is captured in the brightness image, you don't do any subsampling on that. You just leave that as a full pixeled image. But your Chroma image is now containing a lot less information. And in addition to that, colors tend to not change very quickly. So I've decorrelated information between, the color planes, but there's still spatial correlation. Like if I'm on a red pixel, I know that the next pixel right next to me is probably red. So you can still do things like throw away information and easily interpolate that back and not have very much error. So those two things really let you do this notion of subsampling the color planes, because there's not that much information that you lose out on when you do that. And there's the 2 cases I show at the bottom there, 422, 420. The first case is you're just throwing out 1 pixel or every other pixel horizontally, and in 420, you also do that vertically. I think the numbering system that they use is really stupid. You can see how they came up with that and why it is what it is if you just go to a Wikipedia page on Chroma Subsampling. So that is what it is. But the notion is that all that information that was thrown out and no longer has X's in them, you can fill that back in without making too many mistakes. You also gain, if you're doing some kind of like lossless run length encoding, because those values are really small, it doesn't take very much data to encode them. And I think the only other thing I wanted to say is, for those people who are familiar with a little bit of signal processing, another way to think about this is if you know the Nyquist frequency, essentially you're making an assumption here that you need a lower sample rate in color spaces than you do in a brightness space, because things change less quickly. And where you will see errors is around edges. So if I've got a white shirt and I'm standing next to a black background, that's where you will be able to kind of see some of that come through. But in general, sitting at a normal viewing distance and a normal image, these things are not something you'd notice. Like, they do this on Blu-rays and you don't notice it because your eyes are not capable of seeing these small effects on the image. So,
Can I ask a question on that, Nick? So, like, I think this question is totally relevant to what you're talking about, and it's something that's always kind of confused me, and I think it's right in line. So, like, So people who use DSLR cameras, right? And let's say they're using a camera for their YouTube videos, or they're shooting YouTube videos with a DSLR camera that has like a 17 megapixel sensor, for example. Well, when you're using that DSLR to capture video for like a 1920 by 1080 video, is there any? You're saying that? Well, is there any degradation from throwing out all that crap ton of extra data? Because 1920 by 1080, that yields what, 2,073,000 so many pixels. So, you know, what happens? I mean, is it best to? It's kind of confusing. I'm kind of confusing myself. But if you're shooting video for 1920 by 1080, wouldn't it be best to pair a sensor or your output up to match that pixel density for that ratio of that aspect ratio? Does that make any sense?
Well, I mean, there is something a little bit related going on there. I mean, with cameras, you often have this color filter where you don't actually capture every color at every pixel. That's a little different.
Okay.
But certainly related. What they do is they capture green pixels. So this is like almost this concept, but in RGB space. See, when we talk about these 422 and 420, it's always YCBCR, right?
Right.
But like on digital cameras, they actually do subsampled image capture, because at each pixel they only capture one color a lot of times. So one pixel will capture green, the next one will capture red, then the next one will capture green, the next one will capture blue. But that's a little different, and there's a whole literature on how to do that in a way that's optimal and recover a full RGB picture from it.
Okay. All right. Sorry if that wasn't relevant. I just thought of that.
I had 2 points, I guess.
Yeah, go for it.
If one, I wanted to clarify that when you Chroma subsample, if you had a screen that has a certain shade of blue, and you Chroma subsample, it's going to be the same shade of blue. What you're affecting is the speed of the color changing as you move across horizontal or vertical. So if you have color transitions, that's what's affected,
Right.
not the actual shade of the color, which I think a lot of people don't understand.
So
Yeah,
I wanted
this
to
is a
clarify.
totally spatial effect, and if you want to, if you know an image is Chroma subsampled, zoom in really close on an edge, like where there's a sharp color change, and you will see that kind of bleeding where it once probably was pure black and then transitioned immediately to pure blue in the fully sampled image, and once the subsampling happened, some of that blue and black kind of smears together around the edge. If that makes sense.
But are your eyes capable of picking that up? Like that's the whole point, isn't it?
Right. So yeah. So what I'm saying is you'd have to like fully zoom in and stare at something. You'd have to like get your face close up to the monitor and zoom in to that point from a normal viewing distance. And again, this is normal imagery too. So when you start talking about the retro stuff, I suppose there are possible images you could generate that you would see this on more than you would on like real movie video.
Right. That was my second point, is that for graphics, images generated artificially, that correlation that you put on your picture is not as tight. It's more tight for like real world images, I would say.
Right.
And so I just wanted to point that out.
Yeah, I think your 2 little tic-tac-toe games down there was actually a great representation of that, because that also explains that when you have something like even a 480p image, right? That's quite a lot of space you have in order to be dropping little bits here and there. But that also explains that when you're talking about 320 by 240, or actually a little bit less in the case of all consoles, pre-PS1, I would think that I can't be the only person that could see when you start compressing color through the FrameMeister. So that would at least be a visualization of why. Is because when you have so many fewer pixels, you're removing that much more of a percentage of the information.
Well, keep in mind your source data is whatever 240, and then you're expanding that, and then you're throwing it up on some giant monitor. And if you're looking at it at a reasonably close distance, you'll be able to see that, of course. But in a normal viewing scenario, that's the whole point of doing this, is you can really throw away so much data because your original RGB image is super correlated. Like, you can, there's just more data than you really need there, so you're not losing anything.
So a lot of this, in some respects, it really comes down to really limitations of the retina as far as our eyesight's concerned, right? So it doesn't.
Yeah, I mean, as with most image and video processing things, like anything compression related, or this is all taking advantage of your crappy human eyes.
Your crappy human eyes. Next time we hang out, I want to do a Pepsi challenge with you, and I guarantee I'll be 90% right on picking out, which is the from retro stuff, which is the compressed images, which is in 4K, which is in 1080p. So
Sure.
So Nick, really, this is kind of in parallel to how MP3s work, right? Where they cut out a lot of the high frequency content, assuming that you're probably not going to hear that in normal use, right?
Yeah, that's exactly right. I mean, this is the other way to frame it, other than like the pictures I drew at the top, is thinking of it in terms of bandwidth necessary to recreate a signal. And if there are frequencies in that signal that you can't hear / see anyway, you can sample at a lower rate. And so it's the fact that you don't capture those higher frequencies is not a problem.
And of course, it's always use case too. When I'm on the subway with my $17 Bluetooth in-ear headphones, there's no way I'm telling a difference between a 128K MP3 and a FLAC or a Apple lossless or something. So,
Right.
But if whenever I visit a buddy that has one of those really awesome stereos with the the 6-foot speakers and all that, yeah, you could tell a difference 3 notes into any song. So,
Sure.
Same thing with displays.
But on that same token, you have a 320-bit MP3. Most, if not all, people cannot hear the difference between that and a lossless audio file unless you're listening on some very specialized equipment.
So what about those situations, Nick? And this is more sort of pseudo-modern gaming, but like, the PlayStation 3, for example, you have like the limited output, and then you have what they call the deep color, which is the full spectrum. And I play with those, and I turn that off and on like a PS3 to see what the color difference is. And when I turn the full on, things just look a little darker. What exactly is happening? It's like the brightest brights and the darkest darks. That limit is being changed as how dark and how bright things get. Is that even? Go ahead.
I think are you talking about the range, or are you talking about the deep color? They're totally different things.
Okay, so maybe I'm confused. So the deep color and the range, as far as the PlayStation 3 is concerned, for example, those aren't one and the same?
No.
Okay, well, then I don't understand the purpose of deep color, then why it exists.
Deep color is just higher bits. Instead of like 8 bits per pixel, you can quantize it at 12 bits or 10 bits per pixel.
Okay, I understand. So that's not a limitation of a television set. That's just a feature on the graphics of like that system, for example.
Well, I mean, you need higher bandwidth on your HDMI link to support that.
Okay, never mind.
Yeah, I think it's available on the source content. You just, in order to turn that on, your display needs to be able to process that higher bit rate.
Yeah.
Okay.
That was
so Nick,
reasons. Oh, sorry, go for it.
Sorry, I have another question related to Nick's topic, and I'm not sure if there's any correlation in this, but we were talking about DSLRs earlier and CCD sensors, and last time I worked with any of that in electronics, as I recall, the CCD sensors were actually arranged. Each pixel was captured in a grid of 4 sensors, and 2 of them, like this, were green sensors, and then 1 was red and 1 was blue. Right, so there's always twice twice as much green as anything else, right?
Yep.
Is there any relation to capturing a lot more green, and the way that component video is encoded while it's capturing a whole lot of luminosity?
Your photoreceptors in your eye is the reason for that. It's the frequency response of your eyes.
Yeah, it's not. I mean, it's similar to what's going on, but it's not the same thing. I wouldn't draw a direct correlation between that and the chroma subsampling. It's like Steve said, it's your eye sensitivity to green.
That's not what he said. That's not what he said. He said the correlation between that and why when you create luma from RG and B, that G is weighted higher. Isn't that what?
Yeah.
Oh,
Yeah, but it's disproportionate.
Yeah.
sure. Yeah.
Yeah. Steve made a good sentence out of my bad sentence.
Yeah, sorry, I was confused. My mistake. Cool. Steve, your turn. I'm done.
Oh, okay. I'll try to go fast. But so this is something I kind of stumbled upon accidentally on this past Saturday. I was working on some spice simulations for Dreamcast stuff, and I was tweaking up simulation, and I was getting ready to start piecing together all these things I have, like little tiny pieces into one big thing. And I was looking at this. I can't believe I stumbled upon this so accidentally, but I was looking at the C-Sync on Dreamcast, and I was like, I'll copy the Dreamcast circuit exactly. It's like some emitter follower, and then it has like a EMI filter on the output. And I'm like, I'm anal about stuff. I'm gonna look up the EMI filter and see if I can find an ESR, equivalent series resistance, for it, so I could put it in my simulation, right? So I found some data sheets, and I actually stumbled upon their frequency response, and they have really low cutoff frequencies. The EMI, and these are EMI filters used on every signal on the port, on the AV port. So on C-Sync, it doesn't really matter, but they're using this on RG and B and everything else. And because the Dreamcast can output the 480p, the VGA, you need a higher bandwidth. And then these things are like, I mean, I don't know if it's going to show it. I have all my stuff here, but these frequency responses, they cut off pretty low. Usually on something around 480p, you want to have kind of flat to around like 13 megahertz. And the thing I noticed, and this is what really sucked, is they had a BOM and the service manual you can find online for Dreamcast, where they have 3 separate sources for these EMI filters. 2 of them are 18 megahertz cutoff, and 1 of them is a 10 megahertz cutoff. And so it's like super low. And I was thinking, like, this is kind of equivalent to how people, I guess people like Bob don't like putting the 2 low pass filters together, because your high frequencies get like diminished a little bit because you're cascading those filters. This is kind of like the same effect. You're like removing a lot of the high frequency detail from the higher bandwidth video on the Dreamcast. And so I just thought it was interesting, and the reason why this is important is I'm on the front end of our future Dreamcast project. I was attempting to put a filter, and now I have this EMI filter, which is an inductor, capacitor, and another inductor. It's a T structure. That's going to screw with what I had planned. So this kind of like threw like a wrench into like this whole stuff. And so now I'm doing a bunch of analysis. First thing I did is I opened up a Dreamcast, and I put a wire on the blue line, just because on my color bar pattern, blue moves around a lot, before the filter. And so I put it on the scope before and after to see how much this filter actually does. And there was a significant drop in the rise time. So I was just verifying that what I was seeing was held up in real life. And so the next thing I was doing is, I just did this today, is I had a broken Dreamcast, and I went at the motherboard, and I took the EMI filter and attached wires to it. It's not going to focus, but whatever. It's a really tiny, like 0805, and there's 2 two leads on the sides, and in the middle is the ground lead. And so I did that, and then I was measuring the inductance and capacitance with this LCR meter. And I was trying to just get a characterization of this so I can add it to my SPICE simulations and like know how to the best way to work around this, or knowing that this is there now, how I can best tweak it, our stuff, to work with these filters I didn't know were there in the first place. So that's what I was kind of working on.
So I do have a question though, and you kind of skipped over this. You said you found a BOM, the bill of materials for, is that for the Dreamcast original assembly?
I think there was a PAL service manual that was released.
So it was a service manual, it wasn't for like manufacturing.
It's a service manual, but it has all the schematics, board files, or board layout pictures, and a BOM.
Because that was just when you said there was 3 different sources they could pull from, and one had a different rating than the others.
Yes.
That means different Dreamcasts could have slightly different effects on that.
Yes.
Oh,
Yes,
that
that's
shit
why.
drives me crazy. I hate that
I know.
stuff.
I know, and that's why I measured the properties of this, the inductance, the capacitance, and the ESR on these that I pulled from the Dreamcast. Out of those 3 sources, one of them is still in production. I ordered some from Mouser, and I'm going to measure them. And my hope is that the measurements I get off that will be different than these, and then I know which one is the 18, which one's the 10, and I could know the L and C parameters for both, so I could simulate both and see what works the best.
Gotcha.
Yeah. Yeah, it's a kind of goofy. I wasn't expecting. This is totally by accident. I was like working on stuff Saturday, and this like completely threw everything off. The whole like next week and stuff like that. So
for people that are putting Dreamcast through a scaler, do you recommend that they turn on a low pass filter, or does it matter if it's got the the 18 or 10?
They can try turning it off and see how it looks. That's what I would say.
Gotcha.
Are you saying like going through like an OSSC that has the option to
Exactly,
tweak
yes.
that stuff? It's on by default on the OSSC. You can screw with it a little bit, but I have a feeling that that filter in the OSSC is not going to change that much, unless I see if you have the 10 megahertz version, you're probably already cutting off way too low, so that other filter might not even matter. If you have the 18, then I don't know. I didn't spend a lot of time on this yet, and I don't know how much I will spend on it, but you could try it.
Yeah, when I get back in the office, I'm going to do that, because I have 2 Dreamcasts that act slightly different on the OSSC, and then if I could reproduce it, you gotta just tell me where I could test, or where I could take pictures at least, so we could figure out which ones it has on, to see if that's the limiting factor.
Yeah, and I asked, we were supposed to do this anyway for the filter stuff I was implementing anyway, but I asked Nick to expedite the Dreamcast software test. So if everybody use their SNES and Genesis software, we have this pattern where it's like vertical white stripes. We call it like a bandwidth test. It just kind of tests how fast you can change from full white to full black. So you're kind of like testing how fast things can move. And I want that on the Dreamcast to see if I can see any of this stuff on the scope, or if visually you could see like blurring of, like, if it's really low, if the filters filter too much, you have really fine white and black next to each other, it will turn into gray. So
Jeez, I love hearing the behind the scenes from the HD Retrovision stuff, both because it's kind of it's really fascinating to hear the deep technical side of what goes into your cables, because it's like, that's, I'm interested because that's the machines I always work on, and because I'm a bit of an asshole, it also makes me smile when I read some of those trolley posts online about people that say that you just took the generic component converter and stuck it in the cable. That makes me smile even more now when I hear that. So
yeah, there's
Well, this time
Everybody-
we're just ripping off the Behar Bros stuff. So
Wait. You mean you?
all this stuff that Steve's talking about is made up. I mean, at the end of the day, we're just jamming that into a smaller form factor, and that's it.
Did
You
somebody
guys telling
accuse
me
you guys of that?
it's not the off-the-shelf solution?
That's right.
Oh God.
And did
so
somebody actually
impressed.
accuse you guys of that? Because Yoshi
No,
would be
no,
really
no.
upset by that. That's you know.
No. I'm just joshing.
Yeah. Okay. Good.
Yeah, if anybody knows me, they know that I always need to do everything from the ground up because I need to understand how it works, like from the most basic level. So
You're just a front for monster cables.
I'm still hoping for a buyout from them.
oxygen-free
So fine with me.
something.
The dream is get bought out by Monster Cables and retire to a beach in Mexico.
Wait, I
And
thought your
Dr.
dream was to get sponsored by Dr. Pepper.
Well, I don't know if you saw, but I'm part of the Pepper Pack now. Hashtag Pepper Pack.
I think your dick just got smaller. You literally just said hashtag Pepper.
I have to include hashtag Pepper Pack, hashtag ad anytime I tweet anything from whatever they send me. So it's like the law. So gotta be careful about that. Cool. So let's move on to group stuff. We want to do the lighter hidden gems topic first. Cool.
Sure.
I'm gonna
Let's
take
do
that
it.
as a yes, a resounding yes. All right. Group topic number 1 is workshop hidden gems, the tools that we use in our day-to-day working that people might not necessarily think of immediately, that really help us out. The hidden gems.
Yeah.
You want me to go first?
Yeah, go for it.
So, just about every other day when when I finish with a circuit and I'm laying out a board and I'm getting ready to route a board, a lot of things you have to consider. What kind of system it's going into, how much real estate and room's in there. And the best way for me to do things, for anybody to do things, is I use a set of digital calipers. And this will tell me exactly where I'm able to put things and where I'm not able to put things. And fortunately, it does both millimeters and inches, of course. So the metric is great because the millimeters go down to 1,000ths, right? So this is great for evaluating my penis on a month-to-month basis.
So
There
is
goes
clearly
monetization for this video.
So that's fine. So everything that I design and every board that I route out, those measurements are based on just a pair of digital calipers, a valuable tool to anybody who's wanting to do anything similar to this, in my opinion. So that's my hidden tool. It's not really hidden, but Jesus Christ.
That's a cool hidden tool. Is that all you got?
That's all I got. That's all I want to show you right now. I got another tool, but
I'll go next. I can
You
go
wanna
Keep
next.
it hidden. Please keep the
we,
other one.
we don't want to get more letters, okay?
My favorite tool of choice is this magnifying headset with the little flashlight on it. I love this thing. I'm constantly wearing it. I can't right now because I have the headset, but it has 2 magnifying levels that you can select, and it took me about 2 years to notice this after I bought it. So I kind of feel stupid for that. But whenever I'm soldering like T-SOP and whatnot, I mean, I can see it with just my plain sight. But I mean, just having this slightly higher magnification helps so much and makes everything so much easier. And the light on it is just brilliant. I mean, this costs like $10 at Tool Time in Canada, and everyone and their dog should own at least 5 of these.
You have a place called Tool Time?
You have a place called Home Improvement too?
Oh, sorry, I said Tool Time. I meant Tool Town.
Oh,
And a good bonus is if you
Spatula
wear one of
City.
those, you get all the ladies.
And the other tool of choice I really like is these smart tweezers. These are really great for testing incoming boards from the Chinese manufacturers, because most of the sizes of runs that I make usually are hand assembled and they're not machine placed. So I'll get a yield of anywhere between 95 to 98%. So there's always a couple of boards that are failed, right? And And using a pair of smart tweezers, it's really easy to find which components they got wrong, because failures are always related to somebody put, a 10K resistor where a 100K resistor goes, or something like that. So having a pair of smart tweezers really, really helps out. So if you're going to buy
like a multimeter built in, like a basic function?
There's these ones have capacitance and resistance built in, so you can switch to different modes.
Oh, you got to post a link to one of those in the chat. All right, in the video description when we're done, because I got to buy a pair of those.
Yeah, these are great because they allow you to. I mean, you have to be smart about where you're measuring in the circuit. I mean, if you're going to try to measure a decoupling cap,
right,
and you're expecting to measure, like 0.1 microfarads, well, you're measuring the whole voltage rail at that point, right? So you need some smarts going in because you're measuring stuff in circuit. But other than that, it's really good, and I use these on a day-to-day basis.
Right. So if you have two 10K resistors in parallel and you're measuring one, and it's going to read as 5, right?
That's the same thing with the resistors. Yeah.
But for your purpose, that's perfect.
The normal measuring in circuit things still apply here. It doesn't do anything by like a time domain reflectometer, so it knows to just look in a localized area, right? It's not that fancy.
Yeah, no, I haven't checked how it measures capacitance. It's and I mean it's probably pumping out a small frequency and measuring what it's looking like. But anyway,
well, go ahead. I'm sorry, Renee. I was just going to say another great thing about that is if you get a lot of that Chinese manufacturing and they put some questionable parts on there, like some passives, like you can quickly check some resistors and caps to make sure they're not shorted through or open.
Yeah, and I think the best way for in-circuit measuring is you have something works, and you use that as the reference.
Yeah, that's always.
Yeah,
it's a really good point, Steve. That's always what I do is I'll get a known good unit out of a batch, and when I'm testing with the tweezers, I'll just compare what I measure on the known good unit compared to what I'm measuring on the bad unit.
Right.
And the last tool that I have that's always usually hanging up right here is this beer bottle opener. I can't live without this.
Very valuable for popping HDMI sockets off of boards, I suppose. I can go. None of my stuff is actually hardware related because I don't really do hardware. I'm a software guy, so I was going to mention a few things. And I thought actually a couple of things to mention first, not actually even related to writing software, just pieces of software that I use very, very regularly, and without it, I don't think HD Retrovision would exist anymore. The first one being a program called GnuCash, which is spelled GNU Cache. It's a free accounting software, and super useful, super easy once you get over like a one-day learning curve. And it's how we keep track of everything so that we can do taxes and not end up in prison at the end of the year.
That's how we cook the books.
Yeah, that's right.
You need a tool for cooking
the
books.
Somebody mute Steve. So super important, and it's free. So if you're starting a small business and you need to keep track of things, take a look into it. It's nice because it also runs both on Windows and Mac, so I can, since everything is saved off into a shared backup drive that me and Steve have, I can really access it from anywhere. The other software that we use every single day, unfortunately, is a software called Freshdesk, which back in the day when we first started selling stuff, we did support tickets using Google Sheets. Like we'd get an email in, we'd drop information into Google Sheets, like columns to keep track of when's the last time we responded and what the current status is. And it's just a giant mess. And this recent sale, we moved over to Freshdesk, which does all of that automatically for us, integrates directly with our email. We can easily close tickets, see how long they've been open. I mean, it's just been a lifesaver to coordinate responses between me and Steve. It's got some quirks, but definitely super valuable if you're selling something where you need to provide support.
If we didn't have it, I'd say we'd be dead right now.
I think we would just quit. Or nobody would get support, which
Yeah.
maybe that's the better solution. I don't know. So yeah, there's those two things. As far as actually writing software on Windows, I'm sure a lot of people know about this. I don't know if it's really a hidden gem, but I use Notepad++ to write code in any language that I'm writing in because it's syntax highlights.
Absolutely.
But on Mac, there is an equivalent called Text Wrangler, which I think they just changed their name to BB Edit, but I haven't upgraded to it. But exact same type of thing, super valuable for like automatically indenting and syntax highlighting pretty much any language that exists.
Except all the assembly stuff we have to write for all the retro consoles.
Right, yeah, all the assembly stuff. But yeah,
we're in the minority, so
yeah.
it doesn't matter.
But even for the retro stuff, like I have Python code that I wrote to like generate characters that we use to display on the SNES software. So you'd take like a little bit mask and it would convert it to the hex that was required for showing like a little R or a little A. So that's how we wrote the whole text on the screen.
So Nick, I'll have to interrupt you. You talked about automatic indent. So are you spaces or a tab?
I knew that was coming.
I would stop being friends with you if you were a spaces person. I'll just say that.
Good. Okay.
Sorry, one more cool piece of software before I wrap up. It's kind of a combination of a software and a web service, which I don't really use this with HD Retrovision, but I do for other things. It's called Source Tree is the software, and Bitbucket is the web application, and it's basically a Git repository. So if I'm working on something with other people and we're collaborating on code, it's all managed through that, so we can each work on things, update, merge our code changes. And Bitbucket is free up to like a reasonable amount of data, and if you want to, if you need to store more files, you can upgrade for fairly cheap. And SourceTree, the actual application that manages Git, so you don't have to write stupid command line Git, which I'll refuse to ever learn. That's also free. So, bunch of free stuff.
Git's not that hard. Come on.
Yeah, I don't want to Git clone push. Oh, screw it! I just hit the one button. Done.
So you listed most of the useful commands already.
Yeah. I mean, I can't keep track. Man, plus SourceTree gives you nice things because you can see the merges, like the code branches off, and you can see them merge back in, and you get all the comments of what is contained in the change, and so it's way nicer to have GUI. Not that there's anything wrong with command line, but for Git, it's better. So I'm done. Next.
All right, I'll go. I mean, it's not. I was just gonna say something about LT Spice, but that's hardly hidden by now. Everybody knows I use the shit out of that thing. But so probably I think the coolest tool that I have, and it's quite affordable, and I think it's super neat. It's this mechanical nibbling tool. It's a nibbler tool, and what it does is it has this tooth. And you press it and it like nibbles away at thin plastic and aluminum. And what I used to use it a lot for was when we were hand making prototypes of cables where the circuit board would be in. These are like PSP component cable boxes, and you see how like there's that little like circular lip there. This, if I wanted to, I could nibble that away really quickly and make it a bigger hole. I mean, I didn't do a good job here, but I mean, look at the idea. I kind of just nibbled that away with like a few of these snips. And this thing's only like $14. You just Google DigiKey nibbler, and then you'll find the link for it. But it's really awesome for making holes and enclosures. I think it only goes up to just under like 80 thou of thickness. Something like just a little bit more than a PCB width. So it's got to be thin, but usually like enclosure stuff, the walls are that thin, so
Does that
this
thing
thing works.
punch different shapes, or is it all squares or circles, or?
It just rips out. So here's this side, and I'm just gonna do one nibble on it, and it nibbled out like a little rectangle.
Oh, that's cool.
It just nibbles out these like little
Gotcha.
rectangles.
Why don't you just use your teeth?
Damn it! I wasted $14.
I have a similar tool, Steve, where you just have to drill a hole originally. Then you have an edge that you can go around, and you can kind of make out any shape that you want as long as it's bigger than the drill hole.
Yeah, that's what this is
Drill
like
hole.
meant for. Actually, like if you go to that DigiKey thing, they have a scan of the back of the box where it shows like somebody going into aluminum, cutting like a hole in it, because after you drill something in the middle, you could create. It's the same type of concept. I think it's neat for quick mechanical nibbling. So,
And mine's a Klein Tools made in Chicago. Yay!
it used to be made in Chicago. I don't know if they're still here. I guess another thing I think that we probably won't hear in a lot of places, which is why I wanted to bring it up, is unfortunately we've had to do all of our soldering in Rojas in lead-free, and it's really hard to find a good lead-free solder, but I accidentally stumbled across one that I thought worked a lot better than all the other stuff I've used, and I kind of came across this accidentally. At work, we needed a 10 thou diameter lead-free, and the only one I could find was from Kester, and it was this alloy I never heard of. It's a K100LD. Like, this is not the spool for it. I just wrote K100LD because what happened was when I got it at work and I opened it up, like the whole outer thing just fell off, and so there's all this loose stuff, and I'm like, I'm not throwing this out, so I put it on like a little spool, and I add little extra of it. But it has, the reason why I like it is it doesn't have that dull look to it, and it's technically, if you read the data sheet, like they designed it specifically for that, and for getting good wetting and through hole stuff as well. But I use this whenever I got to touch up really small 0402s in lead-free. But in general, I actually am probably going to buy a thicker gauge of this eventually, because the thick stuff you could buy from like just little amounts off Amazon, like in a little tube. I hate it. Compared to this, it's garbage. I mean, if I had the choice for leaded versus lead-free, I'd still pick the leaded, but this is, if you have no choice, this, I really like this K100LD alloy that Kester makes. So I think that's something cool you don't hear a lot.
Do you find you have to use a hotter temperature on your iron to solder with that properly?
Not for this material, no. I think with the other stuff, yeah. That's just what I've felt. I never adjusted it, but when I have to use the other stuff, and something's not working, I bump it up. Maybe I forget to bump it back down, and I don't know. I don't know. Really like it because I'm forced to use lead-free. So, and then the last thing is I love this calculator. This I've had. It's the TI-30X2S. I think is the best calculator. Had it since like high school. Reason why I really like it is it has this X to the -1 button. It's just a push and you get it. And what's really nice about it is why I use it all the time is you could do parallel resistor combinations quick. Like I just did 1K in parallel with 2.7K, and it's was it 759 ohms. So you just do number the -1 plus the other number -1, and then the whole thing -1. It's really quickly you get parallel resistor combinations. That's why I like it. So that's it.
There might actually be an app for that last one, but you would have to have a smartphone in order to download that. So
It would take longer to calculate and open the app and whatnot.
probably,
Just take the calculator.
Calculator apps suck.
yeah,
Yeah.
most do.
I'm going to be a
Terrible.
dick and just point out that if it's just two resistors in parallel, you could just do A times B divided by A plus B.
That's what I was pointing out.
But Nick, that's more number punching than
I
just
know,
doing
I'm just,
minus
I'm
one.
just being an asshole. If you don't have the -1 button,
That's
There you go.
So
just
good.
saying.
Then if you do 3, you just add another -1 and you're
Yeah,
done.
anything more, it's more complicated, obviously.
Gotcha.
So,
Yeah, Nick, what an
Being
asshole.
a jerk.
okay, software person. By the way, thanks for doing all the financials in the GNU cache.
I never used the inverse button on the financials, thank God. Okay, cool. So last time, I think in.
Wait, I had to go, right?
Bob
Oh yeah,
has to go.
sorry, my bad.
Assholes cut me off.
I
I
didn't
got 2
hear
actually.
yours.
Somebody gave this to me. I had my first IT job when I was 19 years old, and when that company moved to Texas, the CIO, he sees me walking through, kind of cleaning up in the last day. He's like, "Oh, hey, I have this at my desk. I thought, maybe you'd like it because, you're like an IT guy and something." He was a nice guy, so I was just like, "Oh, thank you." It was like an eyeglass repair kit or something, and I took it. Just because, the guy was trying to do something nice. I have used this more than every other tool I have combined in the past. When I was like 15 years ago, 20, 18 or something. But yeah, this thing, and now they sell them on Amazon. It's a long red box, and I'll put a link there for anybody that wants it. But I mean, this stuff like this has things that you wouldn't expect to use. So like the one at work I have at the office is better because you probably can't see these, but like the star-shaped ones with the holes in the middle, the safety twerks. You could prepare for a lot of mods and you could do things like, all right, well, I'm gonna get a desoldering gun and solder and everything else, but it's stuff like this, you get halfway opening something up and then you see an odd screw, and something like that is that's saved my butt very often. So the new one I have, I'd leave this in my apartment. The other one I have in my office next to all my tools. But the new one's like $20 from Amazon, and that's my go-to thing anytime I need to like have a weird screw or a weird thing to get into. And not to get all vomit worthy here, but the other hidden gem I have is you four fuckers. Ever since I started the Skype chat with you guys, in the year and a half that we started that, my website's like quadrupled in fucking information. So
Yeah, and my garage is quadrupled in stuff that doesn't work, Bob. Thank you.
you're welcome, Zach. That just shows you how much I like you. That I like you so much that I send you everything I have that doesn't work, just because that's how special you are. Give you all the good broken stuff. But
Thank you, my lord.
Bob, that warms my heart and my
yeah,
loins.
it also makes you throw up, but it's, being able to be working on a really hard problem that's over my head, and what used to take a week of Googling and taking a break is like, hey Steve, that I have the answer 10 minutes later. So yeah, that's awesome.
You have a
weird.
answer.
A better answer than I could have gotten. So cheers with the absinthe to you fuckers. Thank you.
Oh, you're
That's
welcome,
weird, Bob, how
Yeah,
that directly
Bob.
correlates with the amount of free time that we have on our hands nowadays.
Aww.
You guys haven't been getting your cut of the Patreon checks?
Aw.
Is that just me? Shit, I'm sorry,
Excuse me, Bob?
Bob.
Zach's gotten a big cut of it. He's gotten everything that I can't fix myself.
Such a dick.
A little bit, sorry.
All right, sorry for cutting you off, Bob. I did not mean to.
No, it's all
about you.
good.
I was thinking back to better times, like the last podcast where you weren't here. I kid. Okay, so last podcast we actually had somebody in the chat mention they'd like us to dive into software emulation versus hardware FPGA based emulation, and kind of what the differences are there, and maybe some common misconceptions and that whole jazz. So who wants to start us off? I think René is probably the best one to dive in. I think we should start at like as high of a level as possible, just to kind of talk about what a software emulator is versus what an FPGA actually is.
Well, this is really simple. I mean, software sucks and hardware is perfect.
Yeah.
What a way to
Topic
start it
closed.
off, Renee. What a way to
Topic
start
closed.
Yep, Genesis does, Nintendo don't. End of discussion.
Yeah. No, okay. Well, how can I put this very simply? So, the major difference is software does emulation sequentially in a number of sequential, linear, time-devised steps, right? If we're trying to accomplish a certain task, there's going to be a set of time-devised instructions that will lead to us achieving that goal. Hardware is very different. Hardware in an FPGA, you'll design a circuit with VHDL, and it'll kind of just calculate everything all at once, and the output will come out as fast as the gates can react in that FPGA. I'm having a hard time trying to describe it.
Based on that,
easier.
like that whole thing with the gates is like what I always thought of with hardware emulation. That you consider an exclusive OR gate, right? Logic gate. You can implement that with 4 NAND gates. And let's say the NES had some function that used 4 NAND gates to have an input and created an output, like two inputs and created an output using 4 NAND gates. But then you implement it elsewhere using 5 NOR gates. They're technically different hardware. It's different amount of transistors, everything, but your 2 inputs still produce the same output in the same amount of time. And it's I don't know. I don't know if that makes sense to people, but like that's just your inputs and your outputs are equivalent. And when you're doing emulation like that in hardware, where you're emulating that type of behavior, that's what FPGA hardware emulation is. I don't know if that helps.
I guess
let me ask a higher level question here to maybe try to think about this or clarify some things. So when I think of a cartridge with the software on it, what's streaming off that hardware is a stream of opcodes and instructions, right? Do this with this. Do this with this. So when that gets translated in, okay, let's say that opcode instructs us to do the sequence of NAND gates or XOR gates on a couple of registers, right? How is that going to be different when you write a piece of software to do that function than when you write the FPGA to interpret this opcode and run a function on it?
Well, I'm going to say it all depends on the time slices that you're going to be looking at the output, right? If you're trying to emulate an AND gate, right, in hardware, it's very easy, right? You have your 2 inputs coming in, and your output comes out, right? And the output will react as fast as the propagation delay of the FPGA, which I don't know, which like 5, 6 nanoseconds, whatever it is that the chip that you bought, right? If you're emulating that AND gate in software, the reaction time is going to be the speed of the loop of the software that's looking at those 2 inputs and generating the output, right? So you'll have code that is read input A, read input B. Are they equal? Yes, then output 1. No, then output 0, right? So you're constantly going through that loop before you get the output. And let's say that loop takes, X amount of microseconds. Whereas in hardware, we know that an AND gate will easily be synthesized in something that takes mere nanoseconds, right? So if the output of the circuit that you care about doesn't matter, if it takes microseconds to calculate the AND gate, then that's fine, right? But if it does matter, if the reaction time is very important, then the software emulation will clearly be less superior, will clearly be inferior than the hardware emulation. So I guess it all depends on the level of fidelity that you're looking at. I mean, it's not not to say that because hardware is so much faster that it will necessarily have a better result in simulating the same kind of thing that the software will, but the hardware will always have the advantage of speed, but speed might not always be the deciding factor, right?
And you're doing a bunch of that stuff in parallel.
Yeah.
So the CPU has to sequentialize in order.
So it has to compute the output of an AND gate, and then if it needs something else, so it's going to take that output 1, and then you generate a second output 2, and then you were to generate something off of the result of output 1 and output 2 to generate output 3. That all has to happen sequentially, whereas 1 and 2 might be ready immediately in hardware, right? That kind of, am I thinking about that correctly?
Yeah. The more dependencies you stack on your signal output, the longer it's going to take to compute in software. In hardware, you're going to have a glitch state where the gates are transitioning based on those different signals that are feeding into your output, but it's not going to take much longer than the rated propagational delay of the FPGA or CPLD that you're working on, regardless of what dependencies you're putting on your signal, as long as we're talking about a combinational circuit.
So I guess the thing that drives the superiority of a particular type of emulation is, first you need to know the behavior you want to duplicate. Like that's the main point. Like how well you know the behavior is going to affect how well you can duplicate that behavior. And
yeah, garbage in will be garbage out. Yeah.
Right, but the thing that the hardware emulation does is that it's able to implement that behavior much more easily and in parallel processes versus in sequential processes. So that's just saying that the reason why FPGA hardware emulation is can be more superior is because of that. But if you don't know the proper behavior to emulate, then it can still be bad. If you have bad research, then you can have a really crappy implementation.
I think it's what's easily forgotten is whether or not it's a hardware, if it's a hardware interpretation or a software interpretation. The objective is the same. It's an interpretation of what the hardware is doing. So for the NES, for example, I don't think anybody has a die shot of a decapped PPU to know exactly how things are operating on the silicon level. So regardless if it's hardware or software, certain liberties are being taken in regards to how this stuff functions. So just because it's an FPGA-based hardware simulator doesn't mean that it's necessarily superior to a really fine-tuned software emulator that's been around for 10 plus years. I mean, people shouldn't mistake that just because it's hardware based.
That's a really good point, Zach. I mean, given a fast enough CPU, a software emulator can be just as good as an FPGA one, given the proper behavior of the circuit. If you're trying to implement the same behavior in either or, if your CPU is fast enough, the CPU emulation is going to be just as good.
So let me ask a question. Let's say that I perfectly knew how the NES was designed. I knew every single chip, every transistor, and the whole thing. I can recreate this on an FPGA, but I assume there's some theoretical limit to how close you can get because you're not laying down the exact same silicon, right? Your AND gate that gets implemented in the FPGA may be a little bit different than the actual gates that are laid down. I mean, these things all have different characteristics to them, right? You'll never be able to 100% approach something with an FPGA, even if you knew perfectly how it was laid out.
That's a really good point, Nick, because the color palette of the NES has been the point of contention for a really long time, right? I mean, and the number of palettes that come out for the NES RGB is a really good testament to that, right? The the color that's produced on the composite video for NES was was related to like the phase of one of the signals, if I'm not mistaken, right? So and nobody's been able to reproduce that to 100% using the RGB, the NES RGB mod, right? So regardless of how you're going to implement the NES in FPGA, you're not producing the video signal in the same way that the NES was, right? You're trying to output that via HDMI, via
I think
RGB,
you misunderstood
right?
Nick's question. Nick's question was, if you did know that, is there a limit then of what can be hardware duplicated?
I don't mean to interrupt, but I understand exactly what Nick said, and let me try to ask it in a different way that might make more sense to everybody. You have a NES-based software emulator that is fully predicated on, let's say, open decap die shots, looking at every transistor, every gate on the silicon. It's the pinnacle of the emulation possible you can do in software. Let's say you have that same sort of modality, or you have those same sort of circumstances. You have die shots, you have transistor counts, you see everything on the silicon, and you do the same thing on an FPGA. There are no limitations in terms of the interpretation. So having said that, will there be bottlenecks? Where will the bottlenecks be between doing that perfect replication in hardware and that perfect replication in software? Is that what you were trying to ask in some respect, Nick?
Yeah, and I didn't mean to get caught up in like specifically the NES. I
know, it's
used
just
that
an
as an example. Just anything you wanted to duplicate, because the FPGA doesn't have the exact same, like any component you throw on a board has characteristics to it. The delay you're referring to, other things as to how it reacts to signals that may be different than how the FPGA actually behaves.
I think these days, though, like your performance of the gates in your FPGAs, or the simulated gates in the FPGAs, are a subset of, are a superset of the timings in like the older chips. Like, let's say you have setup times of like 20 nanoseconds and hold up times of 20 nanoseconds if we're in the like NES hardware, because we're talking about that on a edge transition. And FPGA can produce even finer stuff than that. It'll meet all the timings by a large margin. So I don't think there is a scenario where you're doing harm by using an FPGA and not like laying out the exact VLSI that the NES chips had, assuming you knew all the behavior exactly.
Right.
So, but the question still is, what would come out on top if you had all of those resources to implement in both software and hardware? What would come out on top?
It's easier to implement it in hardware, though.
Yeah, I think what Nick's referring to is kind of happening right now. I mean, I when he was talking, sorry, we brought up the NES and not Nick.
Right.
But if you know the exact behavior of the CPU, and this happens with the 6502, right? It's not an exact CPU in the NES, but it's kind of related, right? There's actually a website online called visual6502.org, and it's simulating not like the logic behavior of the 6502, but the actual transistor behavior of the die. And it doesn't perform very fast, but it's an exact replica of the transistor die of the 6502. So I think if you have that kind of information of the ICs in the console that you're trying to recreate, then it doesn't matter if you're going to do that in software and hardware. Your simulation is going to be perfect.
But does the fact that your software emulator is sitting on an operating system and things have to be coordinated between your emulation program, your operating system, your video card, all those things, do you run into a theoretical limit there with software? Let's suppose you had...
That's not a theoretical limit. That's a practical limit.
Yeah, I mean, you're talking about
yeah.
cycle. You're talking about cycle perfection, right? So I understand the conversation, but as far as getting a one-to-one cycle perfect emulation of that hardware and software, is that really possible when you have all these other parasitic, ancillary sort of things happening?
I think the question is not whether you need a cycle perfect emulation, but whether you need a frame perfect emulation.
Can you get everything done before the next frame needs to be shot out on the screen? Is that...
Yeah. I mean, is it really necessary? I mean, sure. I mean, you can get into the arguments that do you need the cycle perfect emulation, and maybe on some instances you do, but at the end of the day, your NES only or your console only reacted on the next frame when you pressed a button. So we're getting into the same kind of conversation that we had earlier with the compression on the video signals and the audio signals, right? How much do you need to recreate something that looks perfect to your eye?
I don't know, Renee. I think I can resist that because there's a lot of technology and software that is absolutely dependent on cycle perfect code, and if that isn't honored, and if that is not perfectly replicated, and you'll see this in a lot of modern emulators today that take certain liberties, certain games and certain effects that really count every cycle on that raster line. They fail under certain emulation emulation conditions. So I agree with you, but at the same point, you know, a lot of things that were designed and a lot of games that were designed for these systems are bound to limitations that they were pushing to the absolute max, and therefore I think if you're kind of laxed on not doing a cycle perfect representation of that, you may run into a lot of trouble, or you may run into some trouble at least. I hope that makes sense.
I guess what I meant was not that I'm trying to dispel that you need cycle perfect emulation. What I mean is that your emulation needs to happen on the same time scale as the hardware.
Oh, I'm sorry. Okay. I understand what you're saying.
Because your emulator is going to request a certain number of cycles to be processed by its source code, right? And you're not going to want to process the cycles of, and we're using the NES here as an example. You're not always going to process NES cycles in the exact number of time at the exact same time division that the NES did it, right? Your emulator is probably going to run through like 100 or 200 cycles, and then it's going to the operating system is going to do some other tasks for a while, then it's going to come back to your emulator and service it for a while, right? So yes, contained within itself, it's cycle perfect, but it doesn't happen on the same time scale as the hardware.
So does this really come down? Is this really a question of propagation delay between an FPGA-based solution versus propagation delay based on a software solution, which has all these additional overhead processes like an operating system and other services running in the background? You're saying that, man, not a big deal as long as you have enough time to do it. What difference does it make?
Yeah, exactly. I think given a fast enough CPU, you can make it look like it was the real thing.
Okay.
So in the real-world implementation of a lot of this stuff, right? So all of the hardcore arcade guys, the way they judge it is if it's the exact same experience as the original. So in the competition stuff, you know, if you have one of those super fast slow-mo cameras and you build the controller with a light on it, and you know, if you know, you could fire a Hadouken at the exact same, you know, delay, then it's the same. For your average, you know, one step below hardcore gamer, you know, one frame of lag, if it's always exactly to the microsecond one frame, even crazy people like me could get used to it because it's consistent. It's the variable lag and the variable processing that changes the experience, because it's not consistent. And while things like, you know, games that were written to exploit glitches or to push the hardware to the limits, they might not run properly, but percentage-wise, that's not as many games as that would run fine. It's really the end experience of it. I drew a really super technical schematic on my interpretation of this, and obviously more of a layman's terms, But let me know, like, so, I don't know, will it even focus? No, son of a bitch. Alright. Well, hold on. Okay, alright. So on an FPGA-based thing, I was always under the interpretation that, your input, your controller, goes through, obviously, circuitry on the board, and what the FPGA is actually doing, imagine imaginary chips inside. So assuming two things, assuming that whoever programmed the FPGA knew the exact way that these chips inside of it worked, and assuming that the FPGA is fast enough to actually emulate those, then you could actually get a bit perfect emulation of it through hardware, because it's hardware emulating hardware, and as long as it was written correctly, that's how you can get things like a zero lag implementation of a NES, whereas on the software side of things, and even more complicated drawing, so you have a motherboard with its own bus and its own components and a bunch of shit going through it that runs, your average motherboard and CPU these days, especially if you bought a 2017, is lightning freaking fast. And then you have an operating system with a whole bunch of other shit that it always has to deal with. Windows updates out of nowhere, things running in the background.
Yep.
Then you have a programming language that the software emulator has to be written in. So now you're emulating hardware by writing it in this language. And then you have to take the input and translate it through all of these steps while NIC's Windows updates are happening at the same time. So that was my stupid person layman's interpretation of why so much software emulation, even though it might be the actual emulator written might be perfectly accurate, it still has to deal with all the other shit around it.
Well, Bob, I'm going to interject. So the same requirement that you put on your FPGA, where you said if it was fast enough, it'll look like it's the same thing. If your CPU and your motherboard are fast enough, you're not going to be able to tell the difference either.
Let's not forget. Hold on a second. Let's remember. Like, let's take something like the Super Nintendo. Now, the very, very accurate, cycle accurate Super Nintendo emulator requires at minimum a 3 gigahertz processor to run effectively well. So when we're talking about software versus a hardware FPGA, a gate array implementation, we need to take into consider what overhead must be taken into account when we really want to do a good emulation on something that's 20 plus years old. It's like the Saturn, for example. We can't hardly do it.
Because what you really have is you have your clock cycle that is firing like all these flip-flops in your SNES.
Yep.
As long as your CPU software emulator can duplicate all that in the same amount of time before the next clock cycle hits and all the flip-flops change, then you can do it perfectly. The problem is the practical problem of doing that in that amount of time on the CPU.
Right. And people have told me that they've tested older arcades, and even I believe it might have even been the Atari 2600, where through a software emulator, through my drawing of shit right here, even with all that other stuff going on, they said that they've tested, and it seems to be equivalent. I mean, I'm not talking about look at the screen and guess. I mean actual measurable testing. They think on a fast computer that they can do software emulation for the 2600, and it's fine. You can't notice the difference. So maybe eventually we'll get CPUs fast enough and a little more optimization in the OSs where we can do software emulation of all these things. But I think from a real world implementation is how far along are we in both the FPGA world and in the actual software emulator world.
Well, and another example to attribute to that, if you look at MAME emulation for arcade hardware, right? Mm-hmm. Like, MAME it's very slow to software simulate these Z80 based and with 6809s and 68K based hardware machines from the late mid 1980s to the early 90s. So all of these, so MAME is just riddled with all these speed hacks so that they can get the game sort of running okay, but the input latency is still terrible and things are still. But the point is that You know, a couple of months ago, somebody on Twitter told me that FPGA-based hardware for this sort of retro market would never be a thing, and I think that guy's just kind of ludicrous for saying that. If you want to get real good, a real good representation of this older hardware, software-based stuff just isn't there yet, because I don't think we have systems that have the horsepower, in a lot of respects, to do the newer systems correctly, or at least pretty good. So I think FPGA stuff, just from an overhead standpoint, I think it wins in that regard.
It's easier to implement because, like I said, if you have a clock and a bunch of flip-flops and state machines firing off in a SNES, why don't you attempt to do the same thing in an FPGA and have a clock and flip-flops firing in FPGA? It might not be the exact same structure, but your inputs and outputs are the same. So,
and there isn't a whole bunch of other shit going on interfering.
Yeah, there's no other overhead.
They're all independent of each other on the clock tree. Or
so I would say that. Oh, go ahead. Sorry.
What we've been saying, not directly but explicitly, is that there's determinism in an FPGA that you can't find in a CPU in an OS environment. You don't have that kind of determinism. The OS is going to give you particular time slices to run your software, and you can't guarantee that unless you're running a real-time OS, and nobody using an emulator on a CPU these days are using a real-time OS, so we can throw determinism out the door with a CPU. But you do have determinism all the time on an FPGA. So that's a major reason why the FPGA
is important to put the OS there. I think mentioning that is very important.
So I was going to add is it seems to me like then there's kind of a difference between the scenario. Well, so for an FPGA, like let's say I'm retro USB, I create the AVS, my FPGA.
Good job, by the way.
Yeah, thank you. My FPGA implementation of the NES. Every product that I sell, I'm throwing down the same FPGA. I'm throwing my code on there. It's going to work the same. Effectively a perfect representation of the NES every time. If I write a software emulator and I throw it up on my website for people to download, every single person who downloads that software emulator has got a different machine, is running different things in the background. It's all kind of a big mess. So even if you had the perfect implementation of an NES, it's going to run differently for different people. But let's say I wanted to create a software emulator product where I was controlling the OS and what I was laying down. Let's say like a Retron 5. I mean, they control the OS. They throw everything down. They know exactly what's going on there. There's some, like you say, it's not deterministic, but they have a tighter control of it than someone who's just releasing something for anybody to download onto their PC. So Retron 5 still suffers from few frames of lag and not a perfect emulation experience.
That's a good point, because if Zach is running an NES emulator on his PC and he's looking at a whole bunch of YouPorn videos at the same time, it's not going to run as efficiently as
which is a daily thing.
We're looking at it. Yeah.
That's just a day in the life. Well, I mean, I think it's important, like Nick said, though, there's a certain standardization that's missing when you have an open source or just a free, widely available emulator. I mean, it's an X factor. It's going to run on X hardware. But again, like you look at these things like the Retron 5 and these sort of retro Pi solutions where people are taking Raspberry Pis, and I've played with that pretty extensively, and I've got to be honest with you, I think that's shit. I'm sorry. I know. I mean, people will take offense to that, but I mean, I'm not a hardware snub, but guys, that most of that stuff runs fucking terrible.
Terrible.
It's an ARM processor running a OS.
Sure.
I think the only way you could get down a good emulation is you don't have an OS. Maybe you have an ARM core, and you're coding that without an OS, cycle accurate, whatever, super accurate. But at that point, it's so much more work than just implementing it in gates.
Right.
Yeah.
Yeah, and just to clarify my bitching about RetroPie and all that, I don't, like, I built one for a friend because they just wanted a toy, and I tried playing the first level of Super Mario 1 and died in like a second. It sucks. But for arcade emulation, right, for NES, there's a million options for NES that it's affordable, that people could actually use. For arcade emulation, if I want to go back and play my 10 favorite arcade games, I don't have, $8,000 and a 400 square foot place I could put all these arcade machines. And I do think that that a lot of the Raspberry Pi solutions that has been coming out is certainly good enough for people to mess around with. But a lot of the there's a guy that always contributes to the YouTube videos, Dan, that he always posts about Linux arcade emulation, and you can get a really good setup, but I still wouldn't rely on that for consoles because it's not going to come close, and there's way better alternatives. Whereas there's not for arcades.
It's important to keep in mind that, like, the Raspberry Pi and all of its sort of permutations and what it can do and can't do as far as this stuff goes, it's important to remember that it's a convenience device. And when you have convenience devices like that, much like the Retron 5, there are certain trade-offs. And certainly performance is a big deal breaker, and that is a trade-off. So, yes, of course, it does have its merits, and I certainly won't crap on it for that, but for me, just like you, Bob, I tried playing a bunch of stuff, but Legend of Zelda, I kept falling off the sides in A Link to the Past because, there's like an 87 millisecond latency there, so I'm like, I can't do it.
The one thing though that about Raspberry Pi that sets it apart from every other solution, period, is that around the globe, no matter what language you speak, no matter where you were born, no matter what TV you're plugging it into, everybody's working on the same piece of hardware, period. So that's why a lot of the Raspberry Pi implementations have grown so quickly and so well. Whereas all those, I spent, just as a fun hobby, well, fun for a geek like me, I would always constantly build, a software emulation setup, a MAME machine, whatever else. I was always trying to work on it to get it to be distributed so I could send it to friends and stuff. And it's just, even people that are collaborating, you have a different video card, ATI versus NVIDIA, everything's going to change. So that is the other huge advantage of the Raspberry Pi, is there's just thousands of people working on it, as opposed to handfuls with different, other setups.
Yeah, when we're talking about determinism, we have a much higher rate, a much higher chance of being deterministic in terms of emulation on the Raspberry Pi than any other setup, like you said, because everybody's using the same thing. And I want to use this opportunity to pimp the 3D printed enclosure that I did for my Raspberry Pi.
Oh, that's cool.
Yeah, that's awesome.
That's so cool. Oh, I love it.
Sweet.
And it has the HDMI in the back and so on.
Oh.
See, all you people that are going to the store and trying to get a NES Mini, fuck you, mine's a lot better than yours.
I bought one of the 3D printed SNES case ones, and that was it was really reasonable. It was like $15 or something.
You should take a red marker and try to draw the Nintendo logo on there.
Spell it wrong.
And before anyone asks me if I can print one of these for you, there's like almost 100 hours of fucking 3D printing in this thing. So no, I'm not doing it for anyone else.
We'll just beat you up and take it, but I don't want to go all the way.
You're not driving up here. No way.
So let me ask a question, and this kind of goes to everybody because this really isn't. Oh, it's sort of a technical question, but I guess it's sort of a cost. It's sort of like a cost to like an ROI, to like a return on investment. There was like I said, there was a guy on Twitter who I thought was kind of erroneous in his position on this. But do you think at this era and this sort of the landscape that we're in today, is it plausible that we'll see, and maybe in the next year, several months, or a couple of years, like a window like that we will see companies that are interested in making quality products and not ship products migrate to sort of an FPGA? I mean, Analog NT has kind of done this, but I still consider them kind of niche, right? So like, you have your Retron or your who are the people that make the Retron? Yeah, okay, you have them. Hyperkin. Do you think that we'll see where the costs for this hardware are, it's dropping and dropping and dropping to where everyone or a lot of people will eventually adopt and start doing sort of like these sort of gate replications on FPGAs.
But they've been doing that. That's what those ASICs are. Isn't that's the same thing? It's just the only thing FPGA is different about is that it's easier to produce in lower quantity. Right. As I think is the reason why all this stuff is coming out of FPGAs, because you can't have Brian from Retro USB go to a fab house and be like, I need these ASICs printed, and they'll be like, okay, how many do you want? 1 million, 2 million?
Right, I understand.
Yeah, it's like,
But my
Um,
thing is, I understand what you're saying. I got you.
they've been doing it. Like they've been doing programmable logic stuff.
Well,
I can
system on
answer your
Not
question.
programmable.
system on a chips have existed since
But-
the 90s. But again, it comes back
What
to a
this
question.
thing is.
It comes back to a question of it doesn't matter if it's in hardware or software. 9/10 of it is its implementation and how good it is.
Yeah,
I
it's how well you can define the behavior and how well you know how to duplicate that behavior. That's all it comes down to, and that's why Kevtris and Brian have done so well, is because they spent tons of that R&D on that. The only way what you're saying would end up happening positively is if some company did that same R&D, that same amount
I
of
could answer
work.
your question, Zach, absolutely. Where I am 99.9% sure I could answer it correctly. Companies, even huge companies like Nintendo, when they pump things out in the volume that Nintendo does, I would say like 10% for boutique items like this. 10% of the cost is the actual manufacturing. Then they got to deal with, distribution, shipping, support, blah, 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 blah. So for them to sell a NES Mini or NES Classic, whatever, for, $80 or something, they got to be able to make it for 10. And like Steve said, unless they're going to get millions right off the bat, they can't afford to do it. So until either the cost or the ease of that levels out, you're not going to see something like that from Nintendo.
Well, my counter to that, Bob, is A, we don't know we don't know at what cost Nintendo's getting parts for, and B, if you look at the NES Classic, that's a perfect prime example of where they had an opportunity to sell probably just as many as they were willing to make.
They didn't know that at the time, though. They do now.
Well, of course, this is kind of armchair quarterbacking and quarterbacking, right? But I think that is sort of a little part in history where now people can or companies like Nintendo can better forecast and make projections on sort of supply and demand for this sort of retro hardware niche carve out that they've made. So
Maybe, but my guess is 2 years. For the next 2 years, what we're going to see is guys like Brian from RetroUSB and Kevtris make their custom high-end solutions that, I don't want to use the word expensive because you absolutely get what you paid for and it's worth every penny, but they're not cheap toys. So you're going to see a lot of those. And
it's expensive, it's good, but it's not overpriced.
Right.
What you mean.
And
Very
I think
good
that
description.
the only chance that we're going to get with my guess is 2 years-ish. Is I think a company like Hyperkin might be the only ones to step up to the plate, and I think that all depends on what we used to do at my old company with gray market buys. So we used to buy Intel processors that were legitimately made from Intel. They weren't the ones that were underclocked or anything. They were off the same assembly line, but we just bought them from direct resellers rather than going through Intel's US sales. And because we skipped that, we got them for like 30% cheaper. So if it just so happens that Hyperkin could be in a place where you could buy an FPGA in the quantities that they sell at the right time with the right if all those cards fall into place, you're going to see a company like that probably put one out within 2 years. But only if all the cards fall into place. And there was something online where if you were to buy the actual FPGAs, I forgot the numbers. Let me make shit up. If you just wanted to buy the chip itself, even in bulk, it was $5 each. It wasn't. It was much more. Just picking numbers. But if you bought the kit that it was implemented in the quantities of like 1,000, it was $3. But they wouldn't give you that same discount, the company that makes them, even if you bought more. So that's where these gray market things, and that's where bigger companies that have connections, that will fill the gap for the short term. And that's not a technical thing. That's more of like a sales marketing chain thing. So
I don't think it has anything to do though with like cost of chips. I think they don't have the IP, or the only way they can get the IP is spend the R&D to create it or buy it off somebody.
I agree with that.
Well, companies like Nintendo Nintendo seems throughout their history to be pretty diligent, so they could just take their design docs from the chips that they made and make an FPGA-based solution.
It's not straightforward.
but it's a shitload easier than.
But they would.
somebody
But
doing it
why
at
would
home.
they make an FPGA solution when they could probably stamp ASICs?
Or whatever. I mean, a hardware-based solution is what. I'm sorry, I used the wrong word, but they could do it a lot easier than somebody in their basement scanning for signals trying to make their own would be. But
Yeah, I
it's
think
my
they
guess
would be in the position that they could.
Well, I've heard that
come up with that, but
I've heard that argument before. Someone said that only, for example, like the analog NT or whatever that thing was, and the high def NES, where only people like Kevin and Brian can do that. Well, those guys are the best of the best, but don't sit there and don't tell me that Nintendo can't get an R&D, can't assemble an R&D team to replicate this hardware that they created 20 years ago.
I was saying.
No,
HyperKit.
I'm not. I know you're
Yeah.
not saying that.
I was saying
you're not saying
HyperKit. I'm doubtful. They need to.
Right.
No, but
spend
that's
that.
why a guy like Chris Galizzi is the perfect person for Hyperkin because, I don't know him personally. I did that one interview with him, but it was pretty evident to me that he has a pretty solid grasp on what's happening. A guy like that is going to come out and say, all right, well, let's hire somebody that's already done it or can do it, or, let's not take our in-house guys and spend a year training them. And that guy, J.W. Donnell, he on the NES Dev forums, he has a pretty rock solid SNES implementation. Now, nothing's flawless ever, of course, but I haven't seen it personally yet, but I'm really excited about it. So if one dude can do it, I mean, he's a smart guy. I believe he does this for a living, but still, like, if one guy can do it, Nintendo can do it, they just choose not to, and my very strong guess is just overall cost and timing.
So Zach, let me address your comment here. You're talking about how because Nintendo designed these chips, they should be able to somehow re-implement them in another medium. Let's be clear that any chip that was designed in the 70s or 80s, the design documents that make these chips are patterns of etching that go on a silicon. They're not VHDL, or they're not any kind of hardware description language that is easily it's translatable into a modern medium, right? So there's no equivalence between the photoresist that's going on the die of the NES PPU, let's say, right? It was probably designed just like the 6502, right? They had a huge table, and they physically placed the patterns that they wanted to etch in the silicon onto the table, and they reduced it in size until they could photoresist it.
But the best case scenario would be that they have a logic schematic.
Yeah, and they certainly do, René.
Yeah. But what I'm saying is that those design files are they're physical descriptions of the silicon. They're not HDL. So I mean,
But if you have logic schematics, you could implement that in RTL.
And let's remember that
they have those.
Nintendo didn't create hardly any of this hardware. Rico was contracted to make the CPU, and then all the stuff in the Super Nintendo for the most part too, other than some other things like Sony did the sound chip. But nonetheless, yeah, there certainly would have to be. I'm sure they didn't Chuck Peedle it. I'm sure that Nintendo has comprehensive design docs that show all of the characteristics and the nature of all the circuitry. So I mean, I'm not saying that it's a simple process, René. I'm only saying that if my only contention there is if one guy can do it in his house because he just loves this stuff and he's a genius, I'm sure that Nintendo could assemble a small team of people if they really wanted to create either a hardened ASIC for the modern era or something in FPGA. So that's all I'm saying. That's all I'm saying.
I agree with that.
All right, let's move on to the Q&A stuff. I think we've beat this horse to death. So let's try to get through a few of the quick ones first. Is it possible to identify a one-chip Super Famicom looking at its serial number on the bottom of the system without opening it up?
No, definitely not. And here's exactly why. I've seen plenty of case swaps, and with one chips, absolutely. That same year where they switched over, I've seen serial numbers overlap. So maybe it was a case swap, but I've many times gone into a game store and oh yeah, it's a UN3, and got it and got home and it was a different model from that year. So,
But one thing to say, yeah, like especially when the main board revision, the SNES APU01 and the one chip kind of bled in the same serial number bracket.
yep.
So, and I have a guy here. I have a system. I need to get back to him. I did some work and fixed it up for him. But something to think about. And I was going to ask you this, Bob, because I don't even know. I have heard over the years that while you can't discern just based on the serial number alone, can you take the expansion plate off the bottom? And isn't there something different about the part that they used, or maybe the teeth on the expansion port on the bottom that's different?
So yes for PAL versions, not for US ones.
Okay, I did.
And
okay,
you could certainly narrow it down. So if you see those three dots, it's on my site. In the US, if you see a UN3, you'd know. And I've been to places before. I've asked to open it up, and they looked at me like I just asked to sleep with their wife. They're like, "Get the fuck out of here!" But luckily, places like Retro Games Plus, Chris, the owner, got to know me, so he didn't get weirded out. He was very cool. You get guys like Brooklyn Video Games who open them up and check, and then you get guys like I'm not going to say the name, but there's a couple of stores in Manhattan that do it, and then they tack on $100 to the price.
Oh, fuck them.
Yeah, I don't like that place at all. I don't like them, but that's less common than the other ones. And luckily, guys like Steve are getting to be less rare, I guess is a better way to put it. You go into Brooklyn Video Games, you find a one chip, and you pay a little more for it, but it's still less than you'd pay on eBay, and you basically just paid them to open it up, double check for you, and clean out the console. So. Yeah, that's why I either buy it. You either buy it from eBay and people that will take the top off and actually show it, and you pay a little more, or you have to buy a couple and take a chance. So
sounds like a mess. Sounds like you should just get a SNES Mini and have Voultar mod it.
Yeah.
I mean, that is where that's like, I love the look of the original SNES, right? So I play SNES games because those are the games I like to play. I don't give a shit about the fact that they're retro, if they're new, but it is kind of nice to have that, like, the look of what I played when I was a kid there. That part is neat. Even if I didn't play it, even if I just had it sitting there. So I do like my one chip for that reason, but yeah, if you're just in it for the quality, just get a Mini. Just forget about all this stuff.
Yep.
Fair enough. But the hype between the one chip versus the two chips overblown anyway. Who cares?
I don't think so.
Is Metal Jesus' thought to glue the Zelda X Pro adapter in place a reasonably safe solution for the GameCube? No. All right, let's move on.
No, it's. I gotta
horrible
disagree.
idea.
If you are somebody that's a nerd that likes playing with prototypes, that likes knowing that you're part of somebody that's testing something, then yeah. But as far as a product that's a consumer product that is sold to people that you need to absolutely not. No, you don't just buy it, hit it with a hot glue gun. But like Nick, if you wanted to do like scans to make sure that it was outputting the perfect whatever, and you were just afraid to knock it, yes. Nerds, real nerds, not people that call themselves nerds because that's the cool thing to do these days. Yeah, glue it in place and make it safer. But no,
so I think the key word in this question is solution. It's not a solution.
Was this a serious question? Was this a real question, Nick?
Yeah, it was.
Oh my God, what the fuck is wrong with people?
I mean, I don't blame the person asking the question. I blame the people.
Yeah, of course.
Suggesting this as a solution.
Right.
That's right.
As a solution, no, but for a test thing, yeah, I'd hot glue that thing right in, and that's the perfect use of hot glue because you could pop that sucker right off. So beautiful, but yeah, no, not a solution. But like if you're a tester, a programmer, somebody that's working on something, but yeah, not a solution for the public. No.
I'll try to pick a quick one here. Capcom is partnering with IM8-bit to bring an expensive re-release of Street Fighter 2 to market. But they include a disclaimer that buyers should keep a fire extinguisher nearby. Is there any information about why they might be a fire hazard? René?
Well, okay, let's start by saying that I always keep a fire extinguisher nearby. proof is that I didn't know you were going to talk about that because I didn't look at our spreadsheet. But
IM8-bit addressed the René issue in a lengthy post.
let's just say the board for Street Fighter 2 is being made by Infinite NES Lives, right? And they've proved. I talk to Paul quite often. I think his name is Paul, and he's a really good design engineer. I mean, he's done some really nice products, and he has a cartridge flasher and whatnot. So I'm not worried about the quality of the product that Paul or Infinite NES Lives is going to put out for Street Fighter. I think that's going to be perfect, right?
Yeah, let me just what IM8-bit put out was specifically address the level conversion between 3.3 and 5 volts. So they said that is not what they were referring to. They are just covering their asses because your console is 30 years old and might start on fire for some reason. It doesn't make any sense to me, but I think it was probably Capcom being...
I think
it's lawyers. It's lawyer talk. I mean, in 30 years from now, our SNES and our NES are probably still going to work, but the PS3s and the PS4s are not going to work.
I think the most appalling thing here is that they're releasing Street Fighter 2 and not Street Fighter 2 Turbo.
Yeah,
it's like, why?
A shame.
No, the most appalling thing to me is they're releasing a game that anybody can buy from a game store for $20, if not less, but they won't
20 my
release Mega Man Wily Wars.
It's not
Wily
red.
Wars, yes.
It's not red, and it doesn't have anywhere in sort of its advertisement limited.
Yeah,
It should have been a rare game.
Yeah.
I mean, really, everything is limited.
Let's just get the nomenclature out there. I mean, this is the current era of YouTube personality and celebrity that we live in. If it's not limited, if it's not a hidden gem, if it's not something like that, it ain't worth shit, folks.
All right, we gotta move faster. We're running long, but yeah, go for it.
Sorry, Nick. I just want to be very perfectly clear that the board that is going to be running Street Fighter 2 is going to be a good board, right? There's no reason for people to be afraid that it's going to burn up their console, or vice versa, whether the console is going to burn up because it's old.
Gotcha.
Yep. Good point.
All right. On HD Retrovision's third-party page, all of the component switchers you recommend have a single output. Are there any devices you would recommend for sending a component input to two component outputs simultaneously?
Distribution amplifier?
I have one that's performing
Does the
really,
Extron
really well.
Crosspoint do that?
Yes.
It has
or
8
no?
outputs.
We don't officially recommend anything like that because it's not on that page.
Yeah, we don't. Yeah, we have to be clear here.
But-
We're
but,
not specifically
You're asking
recommending
for
it.
suggestions for
Yeah.
stuff, and I've used a distribution amplifier before.
I have a distribution amplifier in my setup that I'm looking at right now, which is why I'm off camera. It's a Calrad Electronics distribution amplifier. It takes one input and splits it out to 4 outputs, and I've not seen any degradation of signal in it whatsoever. So I would recommend that one. I mean, I didn't get it directly from the manufacturer. I got it from some seller on eBay, but the Calrad device that I'm using, I think, is, as far as I can tell, is transparent. So I would recommend it.
Okay.
Could you guys discuss the so-called SNES Plague? Lots of people's Super Nintendos are starting to develop weird, random graphical glitches. Jeez, that's a mouthful. Some have said that this may be PPU rot due to poor power filtering. Any thoughts on that?
I can tell you that on the 2 PPU stuff, I've replaced my share of video RAM that yielded results similar to that. As far as any sort of PPU degradation as a result of a poorly conditioned supply, I have no data that would substantiate such a claim, Nick.
Anyone else
Steve
familiar with this? Yeah.
Yeah, really. I don't repair.
Maybe they were
my
using
consoles,
ROM
so-
cards that had the wrong voltage.
Ah.
Oh yeah.
Oh, yeah.
You know what I'm saying?
I've been playing too much Street Fighter 2 Red Cart.
Ha.
Oh no, wait! I said that was going to be good.
Would like to hear your guys' experience with HDCP over HDMI. Have you noticed how the PS4 is a big pain in the ass when passing through an HDMI switcher with HDCP on? Other consoles seem to be such as the PS3 don't seem to exhibit this pickiness. HDCP is the whole handshake
High
protocol,
definition
right?
copyright protection. And let me
Okay.
tell you, I had the pleasure of meeting some of that team at CES about 10 years ago. And how can I put this nicely?
Tell 'em to
They
fuck
were
off.
fucking car salesmen. All of them. The techs, too. The techs, the guys that were way smarter than me, designed something because... And they knew damn well that there's too many of us and too little of them, so we're going to find ways of getting around the copy protection, but yet they still wanted to license it to everybody to make their money. So it was just, I can't tell you how much I hate it. Every time a new format's introduced, it's circumvented within 6 months, sometimes within 6 weeks. It's useless. It's never actually stopped anybody from doing any of the things they want to do, but it's marketing and money.
Well, most splitters, for the most part, strip out all of that?
Not most, but if you know which ones to buy, they do.
Oh, I've never seen a splitter that didn't strip out the HDCP.
No.
You weren't paying enough money.
No. Oh, wait, no, never mind. I take that back. Sorry, I didn't get the joke. The one that I love that
That's
also
the
has
joke.
audio broken out is like $35, and the one without audio is like $25. But yeah, it's
Well, I don't think we addressed the question, really.
Yeah,
But I
sorry.
think the point is, because, like Nick mentioned, the HDCP is like a handshaking protocol. When you involve some sort of disconnect and reconnect, that's when you're going to get issues like this with HDCP. And I don't know, it sounds like it's just poorly designed software in one of the devices. Either the Switch, either the display, or the PS4. I don't know. I don't really deal with HDMI stuff too often.
yeah.
Not
The best
yet,
bet
anyways.
is just to get one of those splitters that has the copy protection removal thingy on it, and then just whatever your display is, run it through. Because I think there's 2 ports, and port 1 removes HDCP, and port 2 doesn't, or something like that. So just, I would actually stick. And I have tested, by the way. It does not add lag, and I've tested for reals. I didn't just look at the screen and say it doesn't add lag. I actually put a CRT next to it and other things and stuff. So
Play the fucking game.
I have actual picture proof of this. The ones on Amazon do not add. It would have to be what 1/8 of a frame is what the 240p test suite goes to, and it was dead on. So absolutely 100%, you could use those, and you don't have to worry about changing the signal. You do have to get a different one for 4K use though, up to 1080p 3D. Full resolution. You could use the cheap ones. If you're going 4K in the newer ones, you actually have to use a way more expensive one. Like, add a 0 on to the end of the cost.
Well, so Bob, just to clarify, did you use like a CRT and then like an LCD to test the lag, or?
Well, what I actually did was close one eye and then open the other eye real quick and see if I had them at the same time. So, yeah, it was perfect.
Oh God! Well, then I guess that's more than anecdotal. That's all I needed to hear.
Very repeatable test. I'm really happy that you did
Very.
that, Bob.
Yeah, I
Thank
have
you.
pictures of that on my upscaler comparison page that shows exactly what I did, and I tried like a bunch of different devices. I really got like really boringly nerdy just to check my work, just because I wanted to be able to look into the camera and tell people my findings and know that if anybody ever asked me, I wouldn't lose my temper and swear at them. I could just show them the pictures.
Jesus,
Well,
Bob.
Bob-
Lay off the absinthe.
Bob, that's why we call you the professional nerd, man. I mean, you've got it down.
All right, before this descends into further chaos, we have 3 questions left. I think I'm going to just roll them over to next time. So we're sitting already at 2 hours and change here. So, any last things to get out from anyone?
Maybe we should take like one question from the live chat or something, just to acknowledge the chat.
I didn't really see any flying by, but I don't know if there were any. But I guess we'll give people time to ask something if they have anything. But as always, subscribe if you're not subscribed. That way you'll get the notification when we go live. You can follow us all on Twitter.
Sometimes do 2 notifications, right?
Yeah, that's right.
Or 3.
Me and Steve are at HD Retrovision. Zach, what are you at? Voultar_ModShop.
That's right. You got it.
We got Bob at RetroRGB, and Renee is at DB_electronics.
There's one quick one in the chat. Hey, Corpse, not only have I played Sonic Mania, but wait till tomorrow morning when I release a video on how to do it in 240p.
Wait a minute. Matthew Pickett asks, is Steve broadcasting from the past? What's up with the wood panel?
Hey, I've got that before. We got that on a different live stream.
Oh, I like it.
All right. Cool.
That's awesome.
So, again, if you have additional questions, throw them on the comments. Once this video is finished processing and is up there, we'll try to get to them next time. And if you asked a comment on the last week's and we didn't answer it, I'm gonna roll it over and we'll try to get to it. There were a few we missed. So yeah, I think that's a wrap.
Yep. Good
All right.
times, guys.
See you guys next time.
Have a lot of fun.
Adios.
See
See you guys.